Hi guys, this is Challenge 1C. Our team is Team Eternal Blue, and we are doing Challenge 1 Dynamic Teaching Performance Analysis. The team members were Alex, Connor, Darren, and Scott. This was the brief challenge summary. Feel free to pause the video and read it.
So obviously we had to decompose the problem, which meant we had to obviously analyze it first. So we joined a call, went and found the user journey, and then using that we could then find the data flow and the technical architecture. Here is obviously our user journey. This was our little mind map that we had where we went through to find the flow of how we wanted everything.
Here we have the data flow. We split it into three main parts, and all of the back-end stuff, such as the video processing and speech recognition, was done under the API layer.
So here's the demo for usability and reading, so you're not staring at it all the time. So I'll just quickly run the demo. So I'll show you what images are generated from this. There you go, so we can see it's capturing a frame there. So the frame captured is snapshot. So there's my wonderful face. And that refreshes every second as it takes a snapshot, and then it generates a prediction based on that picture.
This part of the project was focused on creating a speech recognition and natural language processing function for both real-time and historic purposes. For demonstration, I'll start the code now as I talk, and we'll just wait for it to get ready. The first part will be the speech recognition, sentiment analysis, and frequency distribution diagram, all in real time. The top function, as you can see here, is called speech to text, and it ensures that the correct recording device is present and legible, and if so, it transcripts that via an API request. Afterwards, it will send back the user speech for review, as you will see now. Next, it performs some sentiment analysis on both your last sentence and the entire speech when the code is running. Afterwards, it creates a frequency distribution diagram based off of the entire speech, so you can have a more in-depth analysis of your choice of words. For example, at the moment, I have used 8 times, as you can see up here. Lastly, to exit the program, you might want to use something called exit. You might want to say quit, whatever you want to use. I have used exit in this purpose. So if you simply say exit by itself, it will quit the program, and it's all hands-free. So I will demonstrate that now. Exit. So just a couple of the benefits. The live feedback allows the user to make changes while presenting. This works for both the facial recognition side and the speech recognition, and as you saw, with the frequency analysis and sentiment analysis, it can be used in real time. And with the web app, it would allow for historic view, which allows users to compare previous presentation results to see progress. This can be tracked over time, and the user can see where they need to improve on the most.
So we have some stretch goals and some future work that we need to work on. So we'd like to have a model which we can have alongside the current model that we're using based on user feedback to help increase scalability and to make a lot more accurate results. We'd also like to have the deep face model stored against the user, so that way you can have user recognition, so you have more than one person on the screen, you can easily see who is who. We'd also like to have a longevity of data talk, which will help with the preservation of data for historic weights and results. And then we'd also like to be able to pass the webcam through to streaming software, so that way you can use your webcam for multiple things at the same time. Otherwise, your clientele won't be able to actually see your camera. Now, the questions. So question 1, for a presenter to be able to make adjustments to their presentation style live, the feedback they receive should be quick to interpret. How does this tool simplify feedback? At its current stage, it currently does not. However, with the work in progress and future work, we would provide clear and concise feedback for the user on a web service using the data produced from live analysis of their vocal and expressional performance. For question 2, we've got facial recognition data as sensitive information. How does this tool manage to safely secure in the data it receives? When data is being transferred, it will be using current data standards of encryption. All data will be stored on a secure server in a data center with adequate physical security. At the moment, we have no web services, so it's all stored locally, which should help with some form of security. And for question 3, how does this tool cope with more complex presentation structures, such as multiple presenters or interaction with the audience? At the moment, it will take the average of all presenters within the same camera view. However, if the presenters are on different cameras, they would all need the software for this to work. In this case, it will then judge them individually and give them their own feedback, as opposed to giving them group feedback. And that's everything. Thank you.